Hello, today we're going to do two experiments. The first one will be called underwater without getting wet.
The materials we need are really simple. A large glass or a bucket with water, a small glass, and a piece of paper.
So now, let me explain what we're going to do. First, take a piece of paper and crumble it so it hits the bottom of the small glass. Then, turn the small glass upside down with the paper inside and submerge it in the water until it's completely underwater. Finally, take the glass out of the water.
Now observe what happens when you take the glass out. The paper is completely dry, even though the glass was fully submerged underwater. You know why? Well, the earth accumulated in the bottom of the glass and it prevented the water from going up and wetting the paper. Okay, so now for the second experiment, we're going to do an experiment called waves traveling through the air sound. This experiment will help us understand how sound travels through a solid medium, in this case the string, how they can reach our ears.
The materials we need for this experiment are super simple. Two plastic cups and a string longer than 5 meters.
Now, let's explain how to do it. Make a hole at the bottom of each cup. Tie the string to the ends of the cups, passing the string through the hole. Ask a friend to hold one of the cups while you hold the other. Move apart to the strings. Now speak or whisper some words into the cup, and your friend will hear the other.
It's amazing. Even though you speak softly, the sound travels to the string and reaches the other cup directly. The tight string transmits the vibrations of your voice, which then turns back into sound when it reaches the other cup.
What happens is that when you speak, the sound waves from your voice travel through the air inside the cup and makes the bottom of the cup vibrate. Then, those vibrations transfer to the string, which transmits them like playing with a slinky. The waves reach the other cup and turn back into the sound, allowing your friend to hear you.
How does the experiment help us understand the transmission of seismic waves in the earth?
Okay, so this experiment demonstrates how sound travels through a solid medium. In this case, in the experiment, the solid medium is a string. This can represent how seismic waves travel through different layers of the earth, such as the mantle and the crust, just like the string transmits vibrations in the experiments. Rocks on earth transmit seismic waves during an earthquake, helping us detect and understand their propagation.
How can we apply what we learned about sound speed in this experiment to everyday situations?
This experiment teaches us that the sound travels at different speeds depending on the material. In everyday life, we can see this when we hear the thunder. After seeing the lightning during a storm, the light from the lightning travels much faster than the sound of the thunder because the light travels through the air much faster than the sound. This helps us to understand that the sound is slower and that speed depends on the material it travels through.
How does this experiment help us understand the principles of pressure inside the earth?
Well, this is quite simple. The experiment shows how the air trapped inside the glass exerts outward pressure and prevents water from entering. Similarly, within Earth, rocks and other materials generate pressure as they compress. This helps us understand phenomena such as plate tectonics and mountains formation, where internal forces of Earth push outward, maintaining structures and layers immense pressure.
So, how can we apply what we learned about viscosity in this experiment to everyday situations?
Well, in our daily life, we can observe how many more viscous liquids, like shampoo or ketchup, move more slowly than less viscous liquids, such as water or vinegar. This is because viscosity is the resistance a liquid has to move in. The principle helps us to understand why it's harder to pull ketchup from a bottle compared to vinegar, and how viscosity affects the flow of liquids in our everyday environment.